follow on from this discussion, please join me in welcoming Adam Bry, the Chief Executive Officer of Skydio, to the stage to present a tech talk and demonstration. Welcome, Adam.
All right, well, I'll start by saying I'm not even going to try to be more quotable than Palmer. That's a very tough act to follow. I think I heard him say that making your first billion is the hardest, and he called himself a super jingo, which I've also never heard before. So we've heard a few mentions of drones over the last couple of days, and I think that drones are a really interesting technology to view the big themes that we're talking about, of geopolitical competition, national security, and the interaction between technology that's developed in the private sector and the technology that's relevant from a military context. So what I want to do for this session is really dive deep on drones and talk about where these things came from, where we are today, and some ideas on where it's going. So we'll start with a view from Ukraine. So we've heard a lot about drones in Ukraine. This is a video from the early days of the conflict. This is a Ukrainian soldier flying a DJI drone made in China for a surveillance mission. So fortunately, he survived. But I think there's a couple of kind of very obvious observations we can make here. So the first is that small drones are now absolutely crucial tools in any military conflict. This is a theme that's been building probably for the last 3 decades. Drones have been used for all kinds of military applications. But what we're seeing today in Ukraine is a scale and scope that we just have not seen previously. And the second theme is a little bit less obvious, but perhaps even more important, is that relying on drones that are beholden to an adversary can be deadly. So this is a little bit disputed, but essentially what's happening here, he's flying a DJI drone. In addition to making drones, DJI, company ultimately beholden to Chinese national security policy, makes a product called Aeroscope, which tracks DJI drones. So it uses the communication protocol to decode the packets. It has all the telemetry data. And because of that, it has access to the precise location of where the drone is and where the operator is. So both the Ukrainians and the Russians have aeroscopes. But in the early days of the conflict, the Ukrainian aeroscopes stopped functioning the way that they were supposed to, and the Russian aeroscopes kept functioning, which is exactly what you would expect given China's alliance with Russia. And so what's happening in this video is that the aeroscope is being used to target his location. So I want to take a now step back and talk about kind of the brief history of how did we get here. So these things really started as RC toys. So this is the world I kind of grew up in. I grew up flying radio-controlled airplanes. I took it way too seriously. Misspent most of my childhood in my basement building these things. So if you roll back 3 decades, this was kind of the state of play. These gas-powered radio-controlled helicopters, these were very finicky contraptions. It was probably like a 10-to-1 ratio of time spent on the ground, tuning them and trying to get them to work just right to time that you would actually spend flying them. And it was just pure recreation. They're fun to fly. So because these things were toys, toys were some of the first things to be moved to China for manufacturing. And maybe some people saw this coming, but I don't think too many folks would have identified RC toy manufacturing as a critical strategic industry 30 years ago. But what happened is they evolved. So one of the key step changes in technology was electrification. We've seen this play out with other vehicle categories. So this came to drones roughly 20 years ago. The key technology is the lithium polymer battery. This allowed us to get rid of the gas engines. It made them way more reliable, much easier to use, more user-friendly. It also enabled them to get smaller and lighter. They were still pretty difficult to fly. They were still pretty mechanically complex. The next big step forward was the transition to the quadcopter. And the basic insight here is rather than having a conventional rotor where you've got a swash plate and cyclic and a lot of mechanical complexity, you just have 4 motors on there, only 4 moving parts. In order to control it now, you need a slightly more sophisticated control system. So you need sensors like an IMU, basically the same thing that tells your phone which way it's oriented, and sometimes GPS. You need a microcontroller on there to run a basic control attitude loop. And that was sort of the quadcopter. And then the final piece is putting a camera on there. And it just turns out that a quadcopter with a camera on it is a phenomenally useful tool for a really wide range of applications. These things started in the cinematography world. Photographers and consumers were using them to capture really cool videos. But the vast majority of these systems are made in China, and it's been a direct evolution from these things that basically started off looking like toy systems. The other big thing, which is now really crystal clear, is that the civilian quadcopters have wildly outpaced a lot of the traditional defense systems that operate in the same sort of size, weight regime. So what you're seeing on the left here is a thing called a Puma. This is really a product of defense contracting. We heard a bit about that in the previous session. So this is a product of a world where somebody tries to write requirements, they pay companies to go and build to those requirements, and 20 years or so of evolution to get to what we have on the left. It's super expensive, and not to say that it doesn't have useful capability, but its capability is a lot less on most axes that people care about than what you see on the right. So the thing that you can buy at Best Buy for $1,000 is, for 2 orders of magnitude less cost, is in many ways more capable than the thing that's the product of the defense contracting base. And there's also a massive asymmetry in volumes here. So there's probably a few thousand Pumas that have been manufactured in the lifetime, and there's probably a few thousand consumer quadcopters at least manufactured every day. So there's multiple shifts in order of magnitude with the technology here. So because it's 2023, everything has to be done in terms of memes. This is sort of the meme. So on the left is an ad from DJI. It's this friendly consumer quadcopter that you're going to fly with your family. You're going to take nice pictures and video. And on the right is what we're seeing for how that technology actually matters and is manifesting today. So I mentioned that I grew up flying radio-controlled airplanes, kind of the predecessors to the drones of today. I was fortunate to be starting grad school at MIT around the time when you could first take radio-controlled airplanes and put more advanced computers on them, not a little microcontroller, but something that could run real software with real sensors that could sense and perceive the world around it. So this is a video from my master's project. It's about 10 years old. This is an airplane flying itself around in a parking garage, navigating using onboard sensors. And the key point that I want to make here is that the drone game is really just getting started. So everything that we've seen today is small potatoes compared to what's coming. And the big bet that we made when we started Skydio was, starting from a hardware perspective, if you can basically borrow some more technology from smartphones, if you can borrow the processors that are going to smartphones, which have really, really impressive compute capability now, the same cameras that go into smartphones, you can put that on a quadcopter frame, you add the right software, the AI technology to enable these things, that's another step change from a technology standpoint in making these things truly ubiquitous data collection devices. So what does this actually look like? So this is a video of a drone following a mountain biker. So this is a consumer application, but you can see the AI in play. It's using computer vision and machine learning to recognize the mountain biker, to build a 3D model of the world around it, to predict where he's going, to plan a path into the future, to avoid obstacles, and it's doing all of this computation hundreds of times a second. So this is the kind of thing that even the world's best drone pilot would have trouble doing, and it's driven entirely by AI and automation. That same technology foundation can be used to map and understand the world. So what you're seeing here is a product called 3D Scan that can create a digital copy of the physical world. So we thought it'd be useful to not just show you videos of the technology, but actually show you the technology in person. The next step in AI and automation is removing the need to have an operator on the ground at all, having the thing live in an internet-connected charging base station, what you see here, this is called a dock. So this means that the drone is just persistently available, it's network connected, it can be commanded remotely, it can fly itself on a schedule, and this is kind of the final step in breaking the link of needing to have one operator per one drone. So unfortunately, CASA, the Australian Civil Aviation Authority, is, as far as we know, the only regulatory body that asserts authority over indoor flight. So unless we had everybody in the first 10 rows sign a waiver and put down a net, we're not allowed to fly in here. But instead, we thought we'd do something nearby to give you a flavor of what these things actually look like. So we'll teleport out now. This is all happening live. So we're connected to a drone over the internet. It's taking off from a dock. And you'll see it fly an automated mission here. So this is a pre-programmed mission. We heard earlier about the importance of visual navigation. So these drones navigate natively visually. They can use GPS if it's available, but natively they're just flying based on computer vision and can use computer vision to build a 3D model of the world around them, fly very precisely and accurately without needing to run into, without the risk of running into anything. So if we pop up here, you'll probably get a better idea of where we are. We're actually out on Goat Island in the Sydney Harbor. Maybe we can pan around and get a view of the bridge. So this is being operated by our assistant, Ross, up here. There's the bridge. And then when he's done, he can just click return. I'm gonna click return there. So the drone will now automatically, using computer vision, find its way home. So it'll come back to the dock, and you'll see it do an automated landing sequence here. So it uses vision again to recognize the dock. It actually recognizes the Skydio logo there on top. You can see the dock opens up, the pedestal slides out, and it will now localize. It's using its control system to fight any local wind in the environment, and then it'll come in for a precision landing. That's it. Good job, drone. So why does this matter? So the net capability that you basically see there is essentially the ability to put a sensor anywhere in the world you need it, anytime you need it, without needing to have a person there to control it. And if you think about the industries in play, there's so much work that gets done basically to put eyeballs and sensors in important places. So on the left is an image of how bridge inspection has traditionally been done. This is a thing called a snooper truck. So this is a gas-guzzling piece of heavy machinery that people drive along the top of a bridge. It hangs people underneath. It's not supposed to be tipped over like that, but sometimes that happens. People climb towers, people rope in, people fly helicopters, they get in airplanes. And so much of this is basically just understanding what's happening where, when, to have better information to make better decisions. And this is really the core infrastructure industries that the Earth, that the world runs on. I mean, this is transportation, communication, construction, energy. All this stuff is driven by a huge amount of inspection and gaining situational awareness. And drones are in the midst of transforming this, and AI is the next step forward. So I'll just go through a few examples here. So this is a rail yard, BNSF rail yard. So BNSF is one of the major freight distributors across the United States. They have docked drones in their rail yards flying all day long, giving them basically a digital picture of where all these containers are. So the way they used to do this is with a person driving around randomly looking for something that might be lost or missing. Now it's fully digitized in near real time. If you can do it outdoors, you can also do it indoors. So flying based on vision, this is in a warehouse. It's actually conceptually the same application. So rather than looking for containers in a rail yard, we're looking for boxes and pallets in a warehouse. And it's the same story. Right now, people do this very manually, looking around, trying to make notes in a notepad of where a lost pallet might be. The drone can just digitize this stuff in near real time constantly.
Look carefully in the centre of your TV. Inside our Iron Lady, there's a tiny piece of powerful technology.
The sky's the limit as we revolutionise the way we maintain the Sydney Harbour Bridge. She's 90 years old and she is in great shape, but like all of us, she needs to keep up a bit of maintenance from time to time.
In an Australian first, drones equipped with artificial intelligence are being used to map the maintenance needs of bridges across the state.
So we're very excited to have Transport New South Wales as a customer. This is one of the really compelling uses of the technology to do this inspection work that would be very, very expensive to do otherwise. We also increasingly have drones installed in energy substations where they can fly once a day to take pictures of all of the infrastructure, make sure everything's operating as it should be, and respond instantly if there's an incident. So, when we think about the future, I think it's likely that we're going to have autonomous docked drones just blanketing our energy infrastructure, and rather than reactively responding if something goes wrong, we'll be able to proactively inspect and know the state of everything. So far, most of what we've talked about here are kind of the civilian applications of this technology. There's clearly a lot of value here. One question might be, why does this matter in a military context? So if you think about where the technology is going, these are becoming network-connected autonomous devices, and blanketing our critical infrastructure with network-connected autonomous devices, kinetic devices really, that might be calling home to a server in China is probably not an optimal strategy for national security. So it's interesting to think about the reverse. If the market was currently dominated by U.S. companies, what would that mean? So this is Admiral Mark Montgomery. He oversaw operations for U.S. Indo-Pacific Command for the U.S. Navy. So he woke up every morning thinking about what would we do in a conflict in China. And this is what he had to say in congressional testimony. If you had asked me as the J3 at the U.S. Indo-Pacific Command what my dream would have been, we wake up every morning with basically a report generated by U.S. drones flying up and down Chinese infrastructure. And the risk, if we don't, if we don't start to win market share with Western companies, is that something like the opposite of this is on offer for our adversaries. So there are obviously military applications of this technology as well, and network connectivity, autonomy, visual navigation are really the foundations for what we see as the next wave of drone technology. So the paradigm right now is typically you've got one drone per 100 or maybe per 1,000 soldiers, and these things are called organic ISR assets, which means they're carried at the platoon level. They can be launched whenever you need to see what's on the other side of the building or over the hill. This is a great application, but really where these things are going, and where they should be going at least, is the reverse, where you have one soldier who's operating with hundreds of drones that are telling them what's behind them, what's ahead of them, and nobody should ever go anywhere without full certainty in knowing what's out there. So if you think about the battlefield of the future, and I think this is really important to understand, what we're seeing today in Ukraine is really early days. As these things get smarter, smaller, lighter, more network connected, we're going to see just real ubiquity. And the network connectivity is a dramatic step up in the impact that these systems can have. They cannot just be talking to each other, they can be talking to soldiers, they can be talking to other assets in the air, on the ground, in the sea. And it's not just the sort of frontline surveillance applications. So we have hundreds of drones in Ukraine right now. Many of them are being used on the front lines. We've learned a huge amount from those deployments. So we also sell to the US military and other allied militaries. Those sales, seemed honestly a little bit theoretical 18 months ago because the systems were just being used in training exercise. We're one of the companies that's had massively accelerated learnings based on what we're seeing in Ukraine, and we now have a lot of data on what GPS jamming looks like, what comms interference looks like. Our team has shipped a number of software updates to the Ukrainians based on what we've seen, but our systems are also being used behind the front lines for 3D scan applications to document damage, and this is tragically, in many cases, used to document war crimes, but it's also the beginnings of being able to rebuild, just knowing the damage that's out there and what's happening. So I want to conclude with three important themes. So one is that, and this is, I think, the most important one really, is that the game is just getting started. And we talked a lot about drones yesterday. There was a question, of like if China's already won and they're making most of the drones in the world, shouldn't we look elsewhere? I don't think we can take that attitude. These things are just going to get more and more important. They're going to get more and more powerful. And the battleground for military drone supremacy is actually happening in the civilian sector. A lot of the technology that's being deployed in Ukraine now has grown out of the civilian sector, and even the civilian applications of drones, as we've seen, will have military relevance in an actual conflict. And the third one here is that you have to build the hardware to earn the right to write the software. You can't just, I think Silicon Valley, where I come from, is most guilty of this, of thinking that like, we'll just write the software, we don't have to get our hands dirty with manufacturing or anything else. But the folks who are building the hardware aren't just gonna raise their hands and ask for software. If you wanna control the software, which ultimately controls the behavior of the device, you've gotta get your hands dirty, you've gotta do manufacturing. We're one of the few companies that is actually building these things at scale outside of China right now. And I think that that's really crucial for the future of the industry. And I believe very strongly that the West still has an opportunity to win on AI and autonomy. The drone world up until now has predominantly been about hardware and been about manual flight. The future is going to be about automation and AI. And at the very least, I think that kind of technology shift creates an opportunity for Western companies to step up and compete. Thank you.